Saxon Advanced Mathematics, Lesson 44. Our topic today is abstract rate problems. Buckle in, grab a handhold. We're going to figure this out. Let's just tackle the first problem. Peter purchased P pencils for D dollars. No numbers, you guys. We're awash in a land of alphabets. If the pencils had cost X more dollars, how many pencils could Peter have purchased for $20? So as you can see, I'm jotting notes to myself. Okay. The first thing we have to identify is what's the equation we're trying to figure, what's the equation we're going to use as our base? It's going to be rate times price equals pencils. It's kind of like rate times time equals distance. Kind of. Rate times time equals job. This is probably the hardest part to wrap your head around. All right. Our rate. Well, we know we can create two rates out of this. It's either P pencils for D dollars, or it's for D dollars you can buy P pencils, right? We could do it either way. The rate that we want to use is going to be canceled by the price, which is another way of saying dollars, right? So we're going to want to use this one because then the dollars will cancel. So that's the trick to setting up the rate properly, is choose the one you want to cancel based on what you're multiplying it by. So we want the dollars to cancel, so we'll use this one. However, our price, we had a change, right? What if the pencils cost X more dollars? So now the price, or the pencils over the dollars equals the dollars plus X because the price went up. Does that make sense? So this is our new rate. This was the original rate. Okay, so this is our new rate, and we're going to want to use that in this calculation. So our new rate is P over D plus X. And this is, I'm going to put my units in. This is pencils. P pencils, oh my gosh. There, P pencils over D dollars times, there's my first, I didn't fit it in there, did I? Times, how many dollars do we have? $20. And I'll put it over 1. And this is what we're solving for, right? Is how many pencils? And so our final answer is 20P over D plus X pencils. Okay. If you followed that at all, yay, pat yourself on the back. Let's move on to the next one. They're all slightly different, and there's no really tried and true way of knowing exactly what to do. These are a little bit slippery, I would say. The coach purchased B basketballs for X dollars. Similar scenario, right? if each basketball had cost $3 less, jotting notes to myself, how many could the coach have purchased for $200? Okay, so the rate, we've got B basketballs for X dollars. So it's either X dollars for B, I'm just gonna write balls, or B balls for X dollars. Those are our two choices, right? Now, let's use, John does it differently and I don't like how he does it. I want to do it just like we did this one because it's a similar problem, isn't it? So we're going to take rate times the dollars, the price, and that should equal how many we can buy. How many balls? John does it differently, and I don't agree with his way of doing it. Okay, so now what we want to do is this is the original rate, right? The original rate before we did the change, right? Because the price changed. But which one do we want to use? Well, we're going to be multiplying it by dollars, so we want the one with dollars on the bottom, right? We'll want this one. These are our two choices. We like this one. So now we need to calculate the new rate, which is B balls over X minus $3, right? Because the price went down. Oh. Here's what's tricky about it. This is the total cost, and John doesn't make that clear. Last time we were told it was the cost per dollar. So here's the trick on this. Our rate is we have to use the other rate because we have to adjust the dollars. It's X over B minus 3. And we want dollars and dollars to be together right there. Okay, so that's why we can't use that rate. We need to use this rate because this is dollars, whoops, and this is dollars. All right, now to make this into one fraction, we have to multiply this one by B over B, right? So we get our new rate is X minus 3B over B. And that is dollars over balls. Okay? Now, what that means is that in order to solve this problem, we can't use this format because we had to adjust our price. We had to use the other ratio to adjust our price because we had to have dollars on top. And so now the ratio that we've created that is correct is set up to be canceled against balls instead of dollars. So we have to rearrange our equation and we have to say the rate times the number of balls will equal $200. Okay, now I understand why John did it that way, or I remember. It's because of the way he wrote this. We have to adjust the price using this ratio because we have to have dollars on top because we have to subtract 3. And dollars is on the top of that information. So dollars to dollars here, that forces us to use a ratio that has balls on the bottom. We'll multiply that by the number of balls to get our 200. That's why this is kind of opposite of our pencil problem before. That's confusing. That's really confusing. And it's very subtle because in the words, it's not clear that he bought B basketballs for X dollars total. He doesn't say that, but that's implied because that's the way we have to subtract the 3. Okay, let me know if that's confusing to you. It's super confusing. Now we're ready to do the algebra, all right? So balls cancels to balls. That's cool. We're left with dollars. This is dollars over here. We need to get this n by itself. So what we're going to do is we're going to divide by x minus 3b dollars over b. We've already canceled the units on that. Now we're going to have to do the same thing over here. X minus 3b dollars over b. Complex fraction time, we'll multiply this by the reciprocal. Here, let me go to the next page. Okay, this is what I had here. 200 over x minus 3b dollars over b. I'm going to change that dollar sign into the word dollars just to make it a little bit more clear. Okay, this is the bigger line. To simplify this complex fraction, we'll multiply by the reciprocal here. This all cancels. Hannah Cranny demands that we multiply the top by the same, b over x minus 3b dollars. This is a fraction over 1. Now the dollars cancel top and bottom, and our final answer is 200b over x minus 3b, and that's our value for n, which was the number of balls. And I'll just write that there. We defined b as the number of balls. Whew, that's hard, wasn't it? I don't like that problem at all. I think that's really confusing because it all comes down to assuming that x was the total amount we spent on all the balls and not the price per ball. That is annoying, all right? And I need to flag that problem in my book so I don't confuse you all with that. So excuse me while I fix this. Okay, let's try another one. On an assembly line, M workers worked H hours, clever with the letters there, to produce C articles. If D workers quit, how many hours would the remaining workers have to work to produce the same number of articles? Okay, just jotting notes to myself so I'll know what the heck I'm doing. All right, this problem is one of our rate times workers times hours equals, in the past we've said job, but this can also be the articles. Okay? So we need to figure out what our rate is. We know how many workers we have. We know how many hours we have. We know what our job is, right? Our job is equal to C. So all we need is a rate. And that would be the number of articles. It'll be the articles per worker hour. Now, how are you supposed to know that? That you have to deduce from the problem, and that's difficult. Once you've done a handful of these, you'll start to get familiar with the patterns, but that's a hard thing for me to explain, is how you know that that's what the rate is. It's combining these three things, and it's kind of logical. If you're trying to figure out how much time it takes to create this, you'd look at the number of workers and the number of hours. So we'll work on that. All right, so now I'm gonna set this up. My rate a second, I'm finding my place. So my rate is equal to the number of articles, C, over the workers, M, times the hours, H. So M. Okay, so this is the rate that I can use right there. So now I'm going to set this up. Rate times the number of workers times the number of hours equals the articles. Okay, so my rate is C over M times H. The number of workers, well, these guys quit, right? So it's M minus D. And the number of hours is what we don't know, right? Because that is, it's changed now, right? It's not going to be the same number of hours because these guys have quit. We have fewer workers, so T will be the time. How many hours to make C articles? We'll say that is what T is equal to. Okay, that's why we don't use the old hours. It's because that's what it took back when we had M workers, and we needed that to set up the rate. But now that's history. The workers are all still working at the same speed, but there are fewer of them. And so that's what we're trying to figure out. And the number of articles we're going to make is C. All right, so now what we need to do is we need to get this by itself. And the way that we can do that, oh Lord have mercy on us all, let's divide by this. C over MB times M minus D. Okay, and so if we divide this side, then we have to do this side. It's C over MB times M minus D. All right, so we still have to simplify this. I didn't write the words in. Oh gosh. I'll do this one without. It does help if you leave the words in by the letters, you know, like C articles over M workers times H hours, because then we can cancel them all. I'll do that next time. I forgot to write it this time and I don't want to confuse you. So now we're down to just simplifying this. C over and I think, no, that's right. Okay, I thought I was writing H's instead of B's, but I'm fine. All right, so now we have to multiply this by its reciprocal, which would be MB over C times M minus D, right? These two would go together. This is over 1. So, and we're multiplying it, so we squish all that together. So this becomes the numerator and this becomes the denominator, We have to do it to the top. This all cancels. C is over 1 when we multiply it with this. So this C and this C will cancel. So the number of hours that we solve for T is MB over M minus D hours. That's our final answer. This one makes a little bit more sense to me. I think it's a little bit easier to follow. I hope it made more sense to you. Let's talk about Charlie and his dog food, and I'll remember to use the labels this time. Charlie, our good friend Charlie, has P pounds of food. And this would feed M workers, not worders. I mean, maybe they're authors, so that would make them worders, for D days. Or maybe they are a staff of people who produce spelling bees, right? They're like the timers and the checkers and all of that, the master of ceremonies. So that would make them worders too. Maybe you guys, maybe they write dictionaries. That would make them worders as well. Maybe they have a hangman game. Okay, I'm getting distracted by this. But you see what I'm saying. Maybe they are worders and my brain knew something when it didn't write workers. Okay, how long would the food feed? Okay, 30 more workers came. M plus 30 workers. Okay, so my pen's starting to give up the ghost, so I'm switching colors, sorry. So our base equation is what we've been using before. I'm gonna squeeze it in here. It's gonna be the number of workers times, the rate. The rate always comes first. Rate times workers times time equals food. This is kind of like the baby bottle one. And look what I did. I made one with an X and one with a dot. I want them both to be dots. All right, so the rate is going to be the pounds of food per worker day. So that's what we have to straighten out first. The rate is going to be pounds per worker day. And that will be P over M times D. All right, so now we're ready to set this up with our new value for the workers, right? Okay, so our rate is P pounds, I'm gonna write in the units this time, times M worker dash D days. And we're multiplying that by the number of workers, which is now M plus 30 workers. And then we multiply, the time is what we don't know. That's what we're trying to figure out, right? So then times T equals P. The amount of food. P food. All right, so this is all being multiplied, so we have to create another big gnarly fraction because we want T by itself, right? So we're gonna divide by P pounds times M plus 30 workers over M workers times D days. Okay, so what I did was I took all of this and I just rewrote it like so. All right, so I'm dividing both sides by that. So now, heaven help us, what we need to do is we need to move this to the others, we need to divide the other side accordingly, right? So I'm gonna say T equals this over all of that. And I'm gonna write that on the next page. T equals P pounds over P pounds times M plus 30 workers over, this is my bigger bar, M workers times D days. Okay, I can cancel the workers. I'm canceling the units. I'm not canceling any of the values. So the fact that I'm adding 30 there is okay. I get nervous when I see addition when I'm canceling, but we're just canceling the units. All right, so now I want to multiply this by the reciprocal, and that will be, here, let me put my book down. All right, the reciprocal of this will be M times D days over P pounds times M plus 30 workers. I'm getting a little squished here. I'm going to write it all again. So that all cancels, but then I have to multiply all of this by P, and I'm going to put that over 1, P pounds. Okay, so this is my original numerator here, and then I'm multiplying by all of this. M times D days over P pounds. Oh, I don't need to write workers. I crossed it off. P pounds, but I still have the M plus 30. Okay, now I'm multiplying this, right? This is what I'm doing right here, right? There's my pounds. This is the reciprocal of the old denominator. I multiplied the bottom by it and got the whole thing to cancel, but now I'm multiplying the top by this same reciprocal. And look what happens. The P pounds cancel, both the unit and the letter, and I'm left with M D days over the P canceled, and I'm just left with the M plus 30. That's the right answer. Whew. And that was, we set our equation up, it was T equals. All right, it was right there. Okay. That one was a workout, but I do think that all of them were better than the one about the basketball. That one was crazy. So, like I say, if you've hung on it all during this lesson, I'm very proud of you. This was rough stuff. So, good luck. Use these problems as a guide. Watch this video over again. Fast forward to the example that matches the problem you're stuck on, if that's what happens. And be patient with yourself, because this is really, really, really complicated algebra, and you're doing beautifully. Thank you. Goodbye.